Today in class, we started talking about saving and investing, and we are doing our financial unit, which is a little bit new. I am going to go over some of the homework so that hopefully you are able to understand it just a little bit better. We have two different kinds of interest when you're investing money or saving money. The first and probably the easiest way to calculate interest is when you have simple interest. We made a foldable in class and we filled in basically this paragraph, which is describing the definition of simple interest, and it's also going over the formula. It's telling us what I represents in the formula. It's telling us what the capital letter P represents, the letter R, and the letter T, which you can also refer back to that foldable we made. So the question that we started class with says, Aiden makes regular deposits to a savings account to save money for his college. He deposits $1,000 at the start of each year into an account that pays 4% simple interest at the end of each year. Now, the next sentence is very important. It says he does not deposit the interest, which means however much interest he gets at the end of the year, he does not put it back into the bank account. He keeps it and spends it on something. So the things we need to go back and look in the story problem is the original amount that he started with. We need to know the interest rate. And then right now, it's only talking about 1 year. So if we want to know how much interest he earns in only the first year, year 1, we are going to use our formula to find out the interest. So capital P means the principal. The original amount has been listed out for us, but if I was typing this in my calculator, I would type 1,000. Then the next letters are, and it has no symbol in between, so that means times. We also said your interest rate has to be a decimal. We can't keep it as a percent. So I'm typing everything in the bottom on my calculator. The formula also has a letter T, also right next to the R, so that means multiply. And this is our first year. So I would also multiply that answer times 1. When you multiply that completely out, you get the answer of 40. When you type it in on your calculator, you get 40. So that means Aiden earns $40 during the first year of his savings account. So this was the first half of our table that we worked out together. Since it's simple interest, it kind of shows a pattern when you go down. This column right here says he's putting in $1,000 every year. Then the new balance in his account, because he is not keeping the interest in the bank, he's spending it, his balance just increases by $1,000 every month. And then his interest also increases by $40 more every month. So underneath, you can see what I've typed in my calculator just to double check that in year 2, he really did get $80. And if I use the formula, principal, or the original amount, times the interest rate as a decimal, times the number of years, I would get 80. So here I've typed it in my calculator. The original amount, $1,000, times the interest rate as a decimal, 0.04, times, now I'm in the second year, I automatically get the interest rate for that year, which was 80. Okay, if I want to double check row 3 and make sure that I know how to get $120, here is what I typed in my calculator for year 3. the original amount, $1,000, times the interest rate as a decimal, 0.04. Now we're in year 3, so I multiply it by 3, and that says I should get $120, which when I look in this row, it is $120. Now, if we have to keep filling out this chart, the next row says at the starting of year 4, he has $3,000. He adds a deposit of $1,000. Now he has $4,000 in his bank account. We want to find out how much interest he earned during that 4th year. So this is year 4. When we look at this, I'm doing my formula. I have the original amount, or the principal, still times the interest rate, 0.04 as a decimal, times now I'm in year 4. It says it should be $160. So I'm going to write that in, $160. Then the last row is missing the beginning balance for year 5. Well, that number is going to be in the row above what his new balance was at the end of year 4. So I'm going to copy that. He has $4,000 now at the start of year 5. Just like all the other years, he adds $1,000. So now he has $5,000 at the end of year 5. So now we need to figure out how much interest did he get at the end of year 5. So at the bottom, this is what I typed in my calculator for the 5th year. I have my original starting amount, or my principal, $1,000, times the interest rate as a decimal, 0.04. Now I'm in year 5 times 5. So I think it is going to be $200. Now I know in this it has a table, so you can see a pattern. It's increasing by $1,000 every time. Increasing by $1,000 every time. And the interest rate is increasing by $40 every time. Sometimes you're going to have a story problem that is not labeled out for you in a table. And it might say, how much interest did this person earn in 20 years? Well, I'm not going to waste my time making a table going all the way down to 20. So that's why this formula is important. I would put the beginning amount that went into the account times the interest rate times 20, because I was wanting 20 years. So that's why it's extremely important that we know this formula and that the T always means the number of years. If you look on the second page of your homework, now it's going to ask us to compare or answer some questions about this table that we completed on page 1. The first part of this problem, if you look very closely, you will see there are 3 question marks. That means I need to have 3 answers when I'm done. So let's look at the first one. The first part of this problem says how much interest, so that's going to be important. I'm only looking at interest. Did Aiden's account earn from the initial deposit? So that's going to be important. We're starting with the initial amount in year 1. And we want to go to the end of year 5. So I'm going all the way to the end of year 5. So again, we only want the interest column. We're starting at year 1 and we're going down to year 5. Okay, here's the interest column. I'm starting at year 1. I'm going down to year 5. I need to add all of these numbers together. So in your calculator, you need to add 40 plus 80 plus 120 plus 160 plus 200. When you add all those together, you should get $600. So my first answer, I'm going to say that in 5 years, Aiden has earned $600, and it also says explain. So I'm just going to write in the numbers that I added on my calculator. 40 plus 80 plus 120 plus 160 plus 200. And that would be good enough to explain. Whatever you type in your calculator explains how you got your answer. Okay, remember we said there's more than one question mark, so we need to keep reading. From the start of year 6 to the end of year 10. Okay, these are going to be the important parts. Starting at year 6, and I want to go to the end of year 10. So if we focus on just that part of the table, here's the beginning of year 6 all the way down to year 10. I would now need to add these 5 numbers together. When you add those together, you should get 1,600. So on my line, I'm going to write the second answer is $1,600. I'm going to explain it by listing out what I typed in my calculator. 240 plus 280 plus 320 plus 360 plus 400. And that would serve as my explanation. Now the last part of the question says, how do these values compare? When you're comparing something, you need to notice the similarities or the differences in what you're looking at. So the first 5 years, he earned $600. In the last 5 years, he earned $1,600. Some other people might notice the first number is 40. The first number in the second group is 240. So some people might recognize that every amount increased by $200 in the first section compared to the last section. So whatever way you want to compare, this would be your choice. How do you want to compare? On page 3, this is where it gets a little tricky. Compound interest. This is interest that is not only paid on the principal, but it's also paid on interest that you earn. This is a way of earning a whole lot more money because you are not keeping the interest. Okay, not keeping the interest for yourself. You are going to leave it in the bank account. And it's going to increase your money every year because it's going to be left in there. The formula, which we have on our foldable, is the amount in your account is equal to the principal or the starting original amount times 1 plus the interest rate as a decimal, and then the amount of time, which is very important because now it's an exponent. So you have to make sure that you type in the number of years as an exponent. It also explains to you again once more what does each one of these letters in the formula represent. And also the letter A, it tells you the account. So again, this is going to give you a chance to earn way more money, which we'll look at in just a second. So the problem we want to look at now says Lily makes regular deposits into a savings account to save money for retirement because Lily does not want to work forever. It says she deposits $1,000 each year. So this is the same amount being deposited just as Aiden did into her account, and the interest is compounded annually. And the interest rate is still 4%. So this is going to give us a great opportunity to compare what happens when you leave your interest in the account. So we already have our formula listed out. They've started to fill it in for us. The original amount times 1 plus the interest rate as a decimal. The interest rate is still 4%, just like Aiden's. And then the beginning, we only have 1 year because it's saying his first year, how much interest did he earn. If you type all of that into your calculator, you should get $1,040. Now, he is not going to earn $1,040 in interest. That's more than he started with. That's more than 100% interest. He's only getting 4% interest. So, here's what we have to do to find out just the interest. We take the amount of money that we just found out, $1,040. We subtract the original amount, and that's going to give us the amount of interest only that the person earned during the first year. So if I typed this all in my calculator at one time, the original amount is $1,000 times 1 plus the interest rate as a decimal. And then I need to do the exponent button, and this is the first year. That, again, will give you this $1,040. If we subtract the amount we started with, the leftover is just the interest. So now we're going to try that in the next table. I have my formula up here for compound interest. Capital P, the original amount or the principal, times 1 plus the interest rate as a decimal with an exponent for however many years it is. So in our table, they've already filled out a few rows for us. First row, completely filled out. He put $1,000 in the account. Or she. This was Lily's retirement. The amount of interest that she earned during that first year, we said, was $40. So at the end of year 1, she has $1,040. This amount is going to start year 2. For me to keep going and get this information, I'm going to have to type in my calculator this formula and then subtract the original amount just like we did before. So right over here on the side, this is for year number 2. I'm going to follow what the formula says. The original amount times 1 plus the interest rate as a decimal, 0.04, times the number of years. So I'm going to enlarge that just so you can see it a little bit better. Okay, I've got my original amount, capital P, times 1 plus 0.04. That's my interest rate as a decimal, or the R. And the exponent is 2 because now we're talking about year 2. Okay, this amount you get, again, is not just the interest he earned, because that would be more than 100%. I have to subtract the original amount she started with, and then that is going to give me how much interest she earned on just year 2. So if I shrink this back down and move it out of the way, we can take a look at the chart that's already been filled in for us. And indeed, they put $81.60. Now, some people may be wondering, where did they get $2,040? Well, if you remember, we said at the start of the year, she had $1,040. She adds every year $1,000. So now the new balance at the end of the year is $2,040. Then she earned some interest. So I would take the balance at the end of the year. I would add the new interest, which now gives me the overall amount in year 2. So I know this is a little bit tricky. It's a lot of stuff going on. We're going to be spending several days on this. We are going to look at year 3 now. The ending quantity in year 2 is going to be the beginning balance of year 3. Once you know this quantity, if you want to go ahead and fill in the new balance, you could do that. I'm going to add what I start with, including the $1,000 I'm adding. Now I get the new balance. Then we're going to fill in a second how much interest, and then the new total. So below the chart, I have year 3. So I'm going to enlarge these so we can take a look at what I actually typed in my calculator. The original amount, or the principal, $1,000 times 1 plus the interest rate as a decimal, 0.04, exponent, how many years we're on year 3 now. So again, remember, this is a huge number. She does not get $1,124. I have to take this number that shows up on my calculator, subtract the original amount, $1,000. What's left over is the amount of interest. The other thing you need to think about is money is not written with 3 digits behind the decimal. So this third digit, we're going to round it up or keep it the same. So I'm going to shrink these back down, move them out of the way, and now I'm going to write in my interest for year 3. Remember, we just did that and we said it's $1,024.86 because the 4 isn't enough to round up. I'm going to make this bigger so I can write it in clearly. $124.86. And if I continue to add across, just like before, $3,121.60 plus the amount of interest I just earned, I am going to get the total. Okay, I'm going to let you guys add that together because that should be easy for you. Whatever you get as your ending balance, remember, that's going to start year 4. This number has no influence on using the formula, okay? We're still doing our original amount or our principal times 1 plus the interest rate, and then I use an exponent for how many years I'm doing this. So this column is year 4. It's exactly what I typed in my calculator. So let me enlarge that so you can see. Okay, I've got $1,000 because that's my original amount times 1 plus 0.04 exponent 4 because now we're in the 4th year. I get a very large number. Again, all of this, $1,169, is not the amount of interest. I have to go back in and subtract $1,000 because that was the original amount. And what is left over is the interest for this year, for year 4. Remember, money does not have 5 digits behind the decimal. But I am going to use this third digit to know if I round up to 86 cents or keep it 85 cents. So the third digit is an 8, which is big enough for me to round. So when I write in my interest, I'm going to write $169.86. Let me shrink these and get them out of the way. I'm going to make my chart bigger so I can write this in. The amount of interest this time was $169.86 because it rounded up. Okay, again, you're going to find the ending balance from year 3. You're going to write it right here to start year 4. Add $1,000, get the new balance for year 4, and then add your interest. So I'm going to put in whatever you have there, add it with 1,000. You're going to get a quantity. After you get that quantity, you're going to add the interest for year 4. You'll get your new ending balance at the end of year 4, including the interest rate. Okay? Remember, this number is going to start year 5. I'm going to let you figure that out. I'm still going to add $1,000, and then I'm going to get a quantity. Remember, that quantity, whatever is here, has no impact on the interest rate. I'm still using the same exact formula, the original amount times 1 plus the interest rate as a decimal times whatever year I'm on right now. So the last one that I'm going to do for you guys is year 5. Here's what I typed in my calculator. So to start out, I put the original amount, $1,000, times 1 plus the interest as a decimal, 0.04, exponent the number of years I'm on right now, which is the 5th year. I get a very large number again. Remember, $1,216 is not the amount of interest for year 5. I'm going to shrink this down. I'm going to pull up the last step for doing year 5. I take that quantity that showed up in my calculator, $1,216, and blah, 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 blah. Very long number. Remember, money only has 2 digits behind the decimal. I'm going to subtract the original amount of $1,000. What I have left over is the interest rate for this year. Year 5. So, $216.65 because this third digit was a 2, which means I don't need to round up. I'm going to move this back down here under year 5. Going to make my chart a lot larger so I can write this in neatly. $216, and we're leaving it 65 cents. Every time you do the interest rate, we are using this formula. We're using the same exact numbers. The only thing that's going to change is your exponent for whatever year you're working with. So I'm going to let you guys fill in these other blanks because it's just adding quantities. I helped you guys fill in the interest rates because that was the tricky part. And now you guys are going to go ahead and finish all the way down to year 10. There's also a couple questions that's going to ask you to also compare all of this table. It's going to ask you to compare certain quantities in the table. If this still doesn't make perfect sense, don't worry. We're doing this for several more days. If you have questions, come and see me tomorrow. I'll be glad to help you.